record this, I wanted to talk about the fundamental theorem of algebra right quick. That's not where I want to go. There is my paper. And let me put my screen on here. FTA, the fundamental theorem of algebra. Okay, so historically, algebra was like writing a bunch of polynomial equations and trying to factor them and solve them. And so algebra referred to like exclusively to like the sort of like polynomial equations. So there's some like historical context with calling this the fundamental theorem of algebra. Algebra more generally like refers to like a lot of different things now, right? Just basically if we plug a letter in to solve for something, we're going to call it algebra. So we did things, and like if I give you first order, got new pens, got to break them in. If I give you a first order equation like x minus 5, right? This is to the first. Those things should be like really easy to solve. If I give you equations with like squares in them, I don't know. We should be able to solve these things too, right? We should be able to solve these for their zeros. We should be able to find the factors. I probably picked horrible numbers. 4. Put 4x in the middle. I think that just makes it x plus 1. We can factor these things. X plus 1, x plus 3. I can get the 0. I can get the factors. Previously we've had stuff like x squared minus 16, right? We could factor that, and then like there's this thing like we couldn't factor this until we got to the complex numbers, right? And so in the history of math, they had things that were like first order, they had things that were second order. You can have things that are third order. We can have things to like the 10th power, right? We can have things to the millionth. And if they have rational coefficients, there's this question like, can we solve these things? Can we factor these things fully? Are they factorable? Would you want to factor something? No, probably not, right? We probably don't want to do that, but is it possible, right? And so they weren't really sure, even like x to the third, right? We haven't even talked about factoring things to the third. If they have 4 terms, we could probably try to group and factor it, but that's not going to work here. So it's like, how do we do this thing? So we used to do polynomial division. If you do polynomial division, you can think about like pulling out rational zeros. So if you figure this out, there's a way to kind of guess what your rational zeros might be. One of them could be x equals 1. So if x equals 1 is a rational zero, we can pull out a factor x minus 1. And we didn't do polynomial division, but we're dividing this thing by x minus 1. It goes down, and we get it to boil down like power by power, basically, by pulling out our zeros. And so there was a question, can we do this with everything? Is it a valid thing to do to factor this? Are things larger even factorable? So this is just like even a third power, right? We haven't even got to like 4th powers or 5th powers or 6th powers. Can we do things that are larger? X to the 6, right? Is there any guarantee that this is even factorable, or are we wasting our time trying to even try to factor it, right? You don't want to waste your time like trying to factor something that's not factorable. That would be doing a bunch of math for nothing. Who wants to do that, right? Okay, so the short answer to that is yes, everything is factorable. And then the other thing is like it has as many zeros as the power, or it has as many factors or as many zeros as the power. And we've kind of been hinting at this. We've been hinting at this property and kind of just using it. It is like a consequence of the fundamental theorem of algebra. But the other thing I was kind of mentioning in here, in order to factor things, we have to start using complex numbers. I'm doing this wrong. X minus 4i, right? When we were factoring those, we talked a little bit maybe about factoring some of squares. But if you were to solve this, you would get plus 4i and minus 4i for your solutions. Your factors would look like this. And so if we go into the complex numbers, and if we use complex numbers any and everything, all these things are factorable. So there was a gap between them looking at these equations and finding complex numbers as well. So they didn't know if these things are factorable. And then comes along complex numbers, and lo and behold, we can factor everything and all of these things in the complex number field. As long as we're using complex numbers, all of these will have zeros, and they will have as many zeros as they have powers, basically. As long as they're regular, like polynomials, the way that we defined them, right? With the rational coefficients and the positive integer exponents.
And what I also think is really cool is in that example right there, x to the third plus 7x squared plus 7x plus 15. You can kind of visualize what the graph is going to look like, because the cubic part overtakes everything else. So it's like it's going to look, even though it's got a square and you know it's going to look like that, something like that, because that cube is going to overpower all the other exponents.
Yep. And so that's the fundamental theorem of algebra. It basically says we can factor everything if we start going to the complex field. Questions about that? Yeah, but there was a big question on whether you could factor things bigger, right? For a long time.
And I grew up without calculators. We used to have to actually find all the zeros of really ugly polynomials by testing numbers and doing divisions and finding out when it changed from positive to negative.
Oh yeah.
You
do all the factors of this one over this one, the rational zero test.
Yeah, I've had to find all the rational, and we still make people do that, but sometimes I'm like, why do we make people do that? Because I don't know. It's helpful to know sometimes, I guess, to narrow things down.
Ooh. Okay. All right, so we got like 3 problems that are simplifying expressions. Trying to think if there's anything I want to say about fundamental theorem. I think it's about it, right? You can factor everything all the way.
As long as you're using complex numbers.
Yeah, you got to use the complex numbers to do them. There's a weird vocabulary. I did not know this, but there's a word called transcendental number. Have you heard this term, Ms. Watson?
I have.
Okay. Do you know off the top of your head what it is? I'm just like wondering.
Well, is it that it's not e to the pi I, is it? Or
no, but e is a transcendental number and pi is a transcendental number.
Yeah.
Basically, it means you're not going to get it as a solution for one of these.
There we go. Yeah.
It came up in my other class, like completely randomly, because they threw in the Euler's number, right? And so they're like Euler's number is a transcendental number, and so is pi. And then like a student asked me, what the heck does that mean? I was like, I don't know. But it means you can't, it's not a solution for one of these is actually what it means, right?
Yeah.
It's such a weird thing. Such a weird thing to bring up in that class because they try to avoid algebra. That's why they took that class. Okay, so we have these things. Oh man, these look so similar. How do I do
and
this?
One thing I want to say, when I'm grading papers for 4.7, a lot of people would get it down to a certain point, and then I could tell they didn't know how to factor it. They would come up with the right answers, but I was like, well, how did you get that? Anyway, so practice factoring. You need to know how to do that.
All right. So what is the first thing you should do to this thing? If you want to simplify it, it's the F word. Factor it. There it is. How do we factor x squared plus 2x? I bet it has 2 factors. I bet they both start with an X. Probably one's a plus and one's a minus.
Five and
Minus 3. Plus 5 and minus 3. I think I heard like 2 or 3 people. I'll chime in. Good dude. All right, so we got this thing factored. What does this first one look like? I can rewrite my numerator. Say the right word. That's my numerator. I'm writing this over my denominator. And if I didn't have that one, this second one should be really quick. Hopefully it's the same thing on the top. I did this kind of on purpose. Just to see if I could get y'all to see X. Say the wrong thing, but what's going to simplify in that first one? Ooh.
X plus 5.
And
First one, none.
And this one, that one, right?
Right.
I think that's what you're saying. Okay. Well, what about this first one? Can I simplify this at all?
No.
That's
No.
it. There's no common factor. So I'm trying to make sure y'all don't start slashing these things like crazy, right? I guess is what I'm trying to do. Make sure you get the right signs on it. Make sure the signs match up. If the signs don't match up, then we can't simplify it, right? This thing, if I really want to simplify it, what can I write? This is just what?
minus 3.
Yeah, this is just x minus 3, right? It's x minus 3 over 1.
No.
All right, so what about this thing? Probably got to do the same thing. Probably got to factor it to simplify it. All right, so how am I factoring the top?
2x minus x.
2x. Do what now?
Well, I know you're supposed to.
What can I do?
Yeah,
What's the
sure.
first thing you do when you factor something? Pull out what?
Pull out. Well, let's say pull out the 2x.
We can pull out a 2. We can pull out an x. To what?
To the square.
Yeah, and 2x squared. And if we pull out a 2x squared, what are we left with in the numerator?
X minus 1.
And then the denominator, what can we do?
Take out an x. Take out an x.
And that's going to leave me with
X plus 1.
okay.
Mr. Stevens, can you hear me at all? Is
Yeah,
my
I can hear
microphone
you.
good? All right, just check it. Voice is a little raspy, that's all.
Yeah, I can hear that too. I hope you're doing all right.
No allergies, that's all. Thank you.
All right, can I simplify this at all?
No.
The x minus 1 and the x plus 1 aren't going to simplify. Is there anything else I can simplify?
1x.
I can simplify 1x out of this thing. So I can take an x out of this thing. I can take an x out of this thing. So I can simplify this by like a single power of x. So trying to make sure we see those single factors on this problem. Questions about these three? Are we getting these hopefully? Ooh, this is a review, so we've done all this already, right? If there's any questions or anything you're not getting, just like slow me down. It is we're reviewing it to make sure everyone gets it right. And we threw out a lot at you probably within the last couple of days. So it's good to have a little recap. Okay, so we're looking at this thing. Oh man, I might have made this too easy for y'all. So we're multiplying and dividing rational expressions. So what's the approach? What's the strategy for multiplying?
We multiply the numerators and the denominators by each other, so it's pretty straightforward.
Yep, we're multiplying these things straight here, basically. Right? Multiply here, multiply here. Can I simplify this at all? What simplifies?
X minus 2.
X minus 2 will simplify.
X plus 3.
The x plus 3 would be x plus 3.
Then x plus 5.
And x plus 5 with x plus 5.
Guess you can take out the x squared on the top and bottom.
Okay, so I can take out 2 of these x's.
Yeah.
I'm taking out 2 here. Taking out 2 here. 3. Maybe I should be right. This is x to the 3rd. Okay. So I'm looking along the top. This is gone, this is gone, this is gone, this is gone. Looks like I have an x minus 9 left on top. And this guy is over.
X cubed.
Yep, x cubed is still on bottom. Can I simplify this at all? X's and X's, does that simplify?
I want to say yes, but I think it's because they're part of 2 different equations.
I think it's not because it's in parentheses.
You gotta look at this thing, right? That's like a factor. And this is like another factor here. So if it's adding or subtracting any number, right, it is completely different than if it's not adding or subtracting a number. Okay. Questions about this? Well, this one was like fully factored already. It didn't require you to do a lot of factoring work. What about 5?
Multiply as reciprocal.
This is multiplying. So I want to multiply 2 rational fractions, or 2 fractions, 2 rational expressions. This isn't a fraction. How do I make this a fraction?
Factor it.
Ooh, no. Like I do want to factor it, but how do I make it into a fraction if it's not a
Just
fraction?
put it over 1
Yeah, that's what
fraction.
that's what I was trying to get at. Put it over 1, and we do want to factor it.
If the x squared, which is inside of the parentheses to the right, could you take that x squared and then eliminate the x squared that's on the lower left? I don't know if you're allowed, if you can do that.
This one and this one.
Yeah,
Okay, so you're
I'm
looking
confused
at
because that one's inside of a parentheses. It's kind of.
this one is in parentheses. Is this one? This one is also kind of sort of in parentheses too.
Okay.
It's in the denominator.
Okay,
So can we do that? That's a good question.
Well, because one's in factor form and the other one's just a rational factor.
This is attached to what? A minus 36. This is attached to some other stuff. These two things are not the same thing, right?
Okay, so it'd have to be outside of the parentheses.
Yes, it has to be like a parentheses and parentheses that we can group, sort of like this, right? We're making use of the fact that we multiply something. Let me just copy this thing down right quick. So if I have something that factors into x plus 3x minus 2 and something that factors into like x minus 2, x plus 5. The sort of property that I'm using is that I can kind of separate this x minus 2 kind of out from these two things. And they're being separated by multiplication, right? And this is the property that I'm using. This is the same thing over itself. So if I can pull it out through multiplication, and the operation between these things is multiplication, operation between these things is multiplication, then I can simplify things out. So if I'm looking at something like this, I definitely want to start factoring these things. So I think I'll give you like a few minutes, 5 and 6, because 6, I'm going to have to rewrite it, but I'm still going to have to factor it. So I think I want to give y'all just like a few minutes just to work on factoring, to be honest. I think that's probably what we need. I'm hoping difference of squares takes y'all like 3 seconds. Well, maybe not. But hopefully it's pretty quick. There's a difference of squares.
You're talking about the x2 minus 36, x squared, or x to the second power?
Yeah, so x squared
Yeah,
minus
so that's
36.
x plus 6, x minus 6.
Yeah, and this needs to get factored, and this one needs to get factored. This one, can y'all read all these?
Oh, oops. Okay.
X squared minus 16 is this one, over x squared plus 6x plus 9. This is x squared plus 3x plus 28. This is x squared plus 5x. I know it might be a little blurry, but I do got them posted up on Blackboard. So think you told me this one already, huh? X squared minus 36.
X plus 6, x minus 6.
Take square roots. There you go. What about this guy?
X plus 3, x minus 6.
You said plus 3 and minus 6. I think you got them backwards. I think it should be what? Plus 6 and a minus 3, I think. The middle is positive, so the larger one would be positive to make that happen.
And then you cancel out like common terms.
And these two. X squared minus 16.
X plus 4, x minus 4.
And what about this thing?
X plus 3.
Yep, that's x plus 3, perfect square. I would probably write it out twice if I'm going to factor things, right? It might help you out to write things out. And then this one is... Did I mess this one up?
I had to plug that one into a quadratic calculator.
I don't think I meant to do that. I think I might have to change this one. I think it's supposed to be a minus 3. Did I do that wrong?
Did you copy it wrong?
I think I copied it. I think it's wrong in my notes. I think I copied it down wrong. I think minus 3 is what I wanted to do because I think that would give you what, x minus 7 and an x plus 4. Or I didn't change something. I don't know what I did. What about x squared plus 5x? So I'm hoping this one is hopefully pretty quick. What can we do with this?
X.
Just pull out an x and we'll leave it with x plus 5 then. Okay, so we want to rewrite these things. This is x minus 6 on top. We factored these things already in our notes, so I'm just going to jump to the factors. I've got an x plus 6 on the bottom, and I have a x minus 3. I'm multiplying this by an x squared minus 36, which is x plus 6, x minus 6. So what can I cross out? What can I simplify?
X minus 6 and x plus 6.
There is I can simplify out an x plus 6. Here's something else.
X minus 6.
Can I simplify out an x minus 6?
No.
These are getting multiplied together. So I have an x minus 6 and an x minus 6 left on top. On bottom, I still have a what? X minus 3. Can I simplify this out anymore? Well, I can do this, I guess, right? I can write that as a square. Can I simplify that out anymore? No, none of these match, right? I got them all fully factored. None of my factors are matching. Or none of the factors on the different sides, I should say, right? That is it. Okay, so this thing, I am not going to do it like that. The first thing I'm going to do to this thing is rewrite this so that I can actually work it. So they give you a big division bar, write it out horizontally, right? Is the sort of approach you should do. We're going to divide this by x squared plus 3x plus 28 over x squared plus 5x. And if this is division,
And that should be minus the 3x on the second equation.
good call. This is x squared minus 16 over x squared plus 6x plus 9. And I want to convert my division to multiplication. What do I have to do with this thing?
Multiply by the reciprocal.
Yep, I gotta flip this thing. So now my x squared plus 5x is coming on top. My x squared minus 3x plus 28 is going on the bottom. Alrighty then. We have this thing fully factored. We have the factors of x plus 4, x minus 4 for this numerator over here. We have the factors for this thing are x plus 3 over x and x plus 3. Whew. I'm multiplying this by. We got this thing factored as an x times an x plus 5 on top over here. This thing on bottom was the thing that I switched around. And it looks like x minus 7, x plus 4. And now I have a multiplication problem. This should look a lot like the things that we've been doing the previous two problems. So what can I cross out?
The positive 4.
Yeah, the x plus 4. Anything else?
No.
I think that's it. So I'm looking what I have on top. I'm probably going to lead with that x. X minus 4, x plus 5. I have x plus 3. I guess if I really wanted to, you could write it as a square, or you could write it 2 separate times. But I'm probably going to write it like that. Can I simplify this at all? Did I ask that already? That's it, right? They are all different. I have an x by itself. These numbers are all different when we add our subtraction number. Nothing is matching up. That should be fully simplified. Any questions about the stuff we've done? Okay. We got one more division problem, and then we have to start adding and subtracting things. Is this the one we did on the previous page? X squared plus 6x plus 9. I think we did that one already, huh? All right, so what am I doing with this thing? How do I solve this thing? I'm probably not going to write it out like that. If I write it out like this, how do I do this?
So you could take the x squared minus 9 and put that over 1.
So we want to put this
And
over
then
1.
you could, I think you can then convert that to a multiplication of the reverse of that. Where it's
That's
1 over x squared minus 9.
That's exactly what I want to do. 1 over x squared minus 9. We already factored this out previously. This was the x plus 3, x plus 3. This one is what? X squared minus 9 is going to give me.
X plus 3, x minus 3.
It's a difference of squares, x plus 3, x minus 3. And if I set it up like this, if I copy dot flip, if I put things over 1 when they don't have things over 1, I think you will be on the right course or on the right path. X plus 3, one of those things should simplify. This should be what? X plus 3 over x cubed, x minus 3. Is that what I'm ending up with? I think so. And I'm looking at this. Can I simplify anything out of this? Maybe if you want, you could put parentheses around that guy too.
It looks good.
Yeah, this is different from this is different from this, right? None of those things are matching up. Okay. So now we got to add fractions or add rational expressions. So what's the first step if you need to add something that is a fraction that, and these things aren't matching up? What's the first step?
My least common denominator. But,
Least common denominator. So we want to find the least common denominator. What's my LCD here?
Oh, could it be x plus 2 times x minus 3 in parentheses where you put them in parentheses?
Yep.
Okay.
And so if I'm looking at 1 over x plus 2, how do I convert that to my common denominator?
Multiply it by x minus 3.
And if I multiply it by x minus 3 on bottom, got to do it on top.
Oh, okay.
And we're adding what? Yeah, this maybe you're thinking about. I think I think that O might have been like you're thinking about when we were doing solving these things, right? If we're just converting them or adding them or simplifying, we got to do the equivalent fractions. So when you're solving, you can just find the LCD and multiply by the LCD, right? It's a little bit of different approach. What is the x minus 3 missing?
X plus 2.
This is missing an x plus 2. So 1 times x minus 3 is an x minus 3. I have this over my x plus 2, x minus 3. I have this plus 1 times an x plus 2 is an x plus 2. I have this over x minus 3, x plus 2. What's my next step to combine these? What's my denominator?
It's the same.
It's the same. I keep the same denominator of x plus 2, x minus 3. And what do I do with the numerator?
Add them together.
We can add them together. So what is that going to look like? X minus 3 plus what? X plus 2?
Oh, okay, so that would be 2x minus 1.
Yep.
Yeah.
And everybody's favorite question. Can I simplify this?
No.
No, this has a 2 attached to that x. Like that, the 2 should be a dead giveaway, right? This is 2x, this is a single x, this is a single x. There's a different coefficient on the x, so not gonna work. 2x minus 1 is different from an x plus 2 is different from an x minus 3. Those are my 3 factors I'm looking at. Questions about this thing? How to find LCDs? If we have 2 different factors, the LCD is those 2 factors multiplied by themselves. So that is adding. Here's a subtraction one. And if we want to do this, the first step you told me in the previous one, if we were adding and subtracting, is to find an LCD. So what are we gonna have to do with those things in the bottom? Those them denominators, we're gonna have to do what?
Factor them.
Multiply them.
Oh, I believe there's some factoring in store. Oh man, did I say you're gonna have to learn how to factor in this class at some point? I think that might have been said a few times. I think we got one more chapter after all this stuff. After inverses, exponents, and logarithms. I don't think we'll have to factor quite as much there. I don't want to say not at all, but
Yeah.
there's not as much if there is any. Hopefully I did this right. I'm gonna figure this out. What are my two factors for this first thing? Should be plus and minus because that last one's coming up to negative.
I got 4 and 5.
You got 4 and 5. It should be plus 5 and minus 4 so that it adds to a positive 1.
Right.
And what about this one?
Positive 3 minus 4.
Positive 3 and a minus 4. Okay, so this is x plus 5, x minus 4. And this one looks like x plus 3, x minus 4. I know that much. And the first thing I want to find is my LCD. So what do I need in my LCD?
One of each of those factors. So x plus 5, x minus 4, and x plus 3.
What about this x plus 4? Is that good? It's accounted for. Yeah, it's accounted for with this one, right? Okay. I'm looking along this thing. I see an x that is over x plus 5 and an x minus 4. If this is my LCD, I'm asking myself, like, what is this missing? What do I need to add to this thing? I got an x plus 5 and an x minus 4. What else do I need?
X plus 3.
I need an x plus 3. I need it on the bottom. I'm also going to have to go on top. And I think I'm going to do this like maybe a little piece at a time. X plus 1 over x plus 3 over and an x minus 4. And now I'm looking at this one. What will I have to multiply this thing by to get to the common denominator? What is it missing?
X plus 5.
It's missing the x plus 5. Okay, so we're gonna have to do maybe a little bit of work on this thing. kind of knowing where I'm going to go with this thing, I probably want to keep the denominator factored into that LCD, but the numerator, I probably want to do some distribution on. And if you didn't do this all in one step, like the next step, you probably see that you needed to do this distribution. But I want to kind of get it done in one swoop. So x times x is going to give me what? X squared, and I'm going to do x times a plus 3 is going to give me plus 3x. On bottom now, I have the thing that I'm looking for. I have my common denominator. Ooh. What about this? What should I really probably put on this thing? So I don't confuse myself.
Parentheses?
I should probably like put some parentheses around this thing so that I can see that I'm doing some distribution. I'm multiplying this thing by this thing. Give me what? X squared plus 5x plus 1x plus 5, I believe. I could probably simplify it to an x squared plus 6x if I really wanted to. Plus 5. Denominator of x plus 2x minus 4x plus 5. These words get funny when you say them over and over again sometimes. Okay. I have this thing, and I want to subtract this thing. I'm probably going to get sloppy with writing my denominator, but there we go. X squared plus 6x plus 5, x plus 3, x minus 4, x plus 5 on bottom. Move it up. Here we go. I have the first thing I wrote up there minus the second thing I wrote up there. These are all going over the common denominator. What am I doing to that top? Do I want to do it? How do y'all want to do it? I guess that's the question.
You distribute the negative, right?
Have to distribute the negative. So either put like parentheses around this thing, somehow do distribution. I think maybe I do it all in one step. So if I do a minus x squared, I should also have what?
Well, minus 6x minus 5?
Yeah, exactly. You should distribute everything is getting a minus sign. You're getting a minus sign, and you're getting a minus sign. It's a minus sign giveaway. Sorry. What do I have? A big mess, probably, right? But hopefully we
Well,
can
the x
clean it up.
squares would, sorry. I was gonna
Yeah,
say the x squares would cancel each other out immediately.
yeah, we can simplify out the x squared. This is a positive x squared and a minus x squared.
And then negative 3x minus 5 is all that you have left.
I have a minus 3x minus 5 on top. I have an x plus 5. I have an x minus 4. And I have an x plus 3. And I probably didn't pick the best addition and subtraction problems because none of them have anything that simplifies out afterward. Sometimes things do simplify out. So we got to look at these. There's no common factor between 3 and 5, so that's kind of a dead giveaway. There's no GCF there, right? If there was a GCF, we might have to pull a GCF out of these things. But there's not one there. We might be able to pull a negative out, maybe. The book suggests pulling out the name, pulling out if you really wanted to rewrite. Minus 3x minus 5 is a minus 1 times what, 3x plus 5? But none of our factors are going to match up, right? Is the important thing. So that is it. How many more I got? Oh, okay, these three, and then we got a few more solving them, and then there's a word problem. So this is all about the domain and finding the asymptotes. So we got three functions, f, g, and h. We want to find the domain of these things. We want to find the asymptotes. We want to know holes. That's the other thing. Show them all. There we go. I got my stand to balance. All right, so if we want to find the domain, what are we going to have to do? What's the, well, I guess the better question is like, what is the restriction on the domain here?
There, set it equal to 0.
Set what equals 0?
The denominator.
Yeah, the denominator, right? Thou shalt not divide by 0. So if we want to set the denominator equal to 0, you might have figured it out, but we're going to have to factor some of these things, right? So if we go, x plus 2 is not equal to 0. What's my domain here? What's the domain restriction? X cannot be what?
2.
Yeah, so you do have to be careful with signs so that people don't mess up their signs. But minus 2 plus 2 would give you the 0. Okay, so I'm just going to go through, I want to go through and talk about, I guess let's just do the domain right quick. Probably the way to go about this. And then we'll talk about asymptotes, and then we'll talk about holes. And we'll talk about the other asymptotes. Same thing here. If I want to know my domain, I want to know where this thing is 0. That's where it cannot be. There are probably two ways to solve this, right? We use what, the square root property, if you wanted to. The other way is, what is this?
Difference of squares.
It is the difference of squares. I can look at it as x plus 5, x minus 5. And if I want to do my domain restrictions, I should have what? 2 domain restrictions. This one gives me the negative 5. This one gives me the positive 5. So x cannot be positive or negative 5. You'll get the same thing if you do the square root property, right? This is not a negative 5, right? Here, what's my domain? I gotta do some factoring. 3x squared plus 6x plus 12. I'm coming back engineer here, so it's like, I hope I did my distribution right in my head and stuff. But I think if we factor this, there is a GCF that we can factor out of 3, 6, and 12. I think even if you miss your GCF, I think you still get the same zeros. We want to know that this is not equal to 0 for our domain. Take our denominator, set it equal to 0, or set it not equal to 0, whichever way you want to go. But I think this is giving me x plus 2, perfect square. So this has a domain restriction of what? X cannot be a minus 2. And it repeats itself, but we get x's cannot be a minus 2. So we did the domain. And you might want to note, are these fractions reduced at all? When I did the domain, do I reduce the fraction at all?
You mean like simplify it?
Yeah, did I do that?
If it doesn't equal 5, it doesn't equal -5.
Did I reduce with the numerator and denominator at all before I just started doing these things and setting this equal to 0?
Only for no.
Nope, didn't do it for any of them. So don't simplify this, right? Before you simplify anything, I mean, I guess we could factor things, right? We did factor the denominator here. But I didn't simplify anything out, right? I did factor out my denominator here, but I didn't simplify anything out with the numerator. And I probably should really start factoring things out. This has the GCF of x, and it leaves me with x plus 2. And I think I have something in common here with 3x. And it leaves me with what, x plus 3? So I didn't factor or simplify anything out through the numerator denominator, right? I did factor out the denominator, but your domain restrictions come before you start simplifying things out, is what I'm trying to get at here. If I want to know my asymptotes, what do I have to do for my vertical asymptotes? That's my next question.
Matt, wait, what's going on with number 13?
11, 12,
I mean, number 12.
what about it?
That doesn't factor like that, does it?
Which one?
The bottom of the denominator of number 12.
Yeah, I factor out 3, right? Plus 6x plus 12.
Yeah, but x squared plus 2x plus 4 won't factor.
Oh, dang it. I meant to do plus 4 here.
Oh.
This is what I do for doing things. This should say 12x. I meant for it to factor evenly.
Okay, that's why I was going, where did you get that domain?
Good call, good call. That should say 12, yes. Okay. So if we look at the domain, we want to do the domain before we start simplifying things out. If I do my vertical asymptote, what do I want to do? How do I find my vertical asymptote?
Set the denominator equal to 0.
There's one thing I should really do first before I find my vertical asymptote. If I'm looking at this equation, what's the thing like you're probably itching to do?
Simplify it.
And if we simplify it, what's my denominator now?
1.
Yeah, is that going to ever be 0? What's my vertical asymptote now?
None.
Yeah, there are none. So what's happening with this x equals a minus 2? What's happening there? So we can't plug it in, but it's not an asymptote. So what does that make it?
A hole?
It's a hole. All right, and so we'll talk about horizontal asymptotes in a second. So I'm not forgetting about horizontal asymptotes. Right now, I'm just trying to talk about vertical asymptotes and domain and how those things relate. So if it factors out, we still can't plug it into our function, but it's not an asymptote. It's not like shooting off to infinity there. It just creates a hole in our graph. Same thing here. What do I want to do with this number 11? What's my vertical asymptote?
X minus 5 simplify out, so it would be -5.
It's the -5. It's where your x plus 5 is equal to 0. Okay. I got a vertical asymptote at -5. Is there anything else you can tell me about anything else here? What about this thing? What is this?
5 is a hole.
Yep. At x equals 5. So I could go plug this back in probably and actually find a value. I think it'd be 1/10 if I plug this in. It'd be 5, 110. There'd be a little hollow dot there basically. I'm just looking at the x value though. There's going to be a hole at that x value. And the last one, there, I don't think there's a lot I can simplify here. I can maybe take out the 3's. What's my vertical asymptote? Do I have a vertical asymptote here?
-2.
Should be the x equals m minus 2. Are there any holes here?
No.
No, there shouldn't be. Okay, so we did asymptotes, we did holes, vertical asymptotes. We want to do horizontal asymptotes now. Do you all remember the rules for horizontal asymptotes? That's the question. What did we look at for horizontal asymptotes? And I wouldn't look at the factored version. I would look at this guy, the expanded version.
Powers of the leading coefficient.
Okay. We look at the powers of the leading coefficient. So I'm giving you like pretty much an example of each, right? It's greater on top than it is on bottom. It's greater on bottom than it is on top. Here they are the same power. So each of these, I hope you realize you're not going to solve them the same, right? Right off the bat. I'm giving you an example of each. So if it's greater on top than on bottom, does that tell me anything? Does it tell me it goes to 0 or does it tell me nothing? Or does it tell me to take the leading coefficients? I think those are the 3 options I got. So if it's more on top, what is this going towards as it goes off to infinity? What can we say? Ha, ha, ha. That's what I can say. What's my horizontal asymptote on 10? Do you all remember this? Do y'all remember any of these?
I remember the formulas, but I forget how it goes. Would it get larger?
This one? So it's a larger power on top over something smaller on bottom.
Yeah.
So think of something really large. I don't know, infinity or something. Or something really kind of relatively small, like 1. So I'm thinking of like maybe infinity over 1 for this thing. And this thing I'm thinking maybe like 1 over something really large. So one of them, I'm going to give you a hint on these. On these, one of them's going to go to 0 and one of them's not going to tell you anything. So which one is which and why?
The first one has no asymptote.
All right, so there's no horizontal asymptote on the first one. And on this one, we should get a horizontal asymptote of
0.
0, and you should really tell me what is equal to 0.
Y.
It would be the y value because it's a horizontal asymptote. All right. Do y'all understand where these things are coming from? These two. If I have something really large on top over something smaller, this thing is just, it's shooting off to some number. We can't really say it's leveling out, right? If we have something really large on top, there's nothing we can say about this as it goes off to infinity. But if it's larger on bottom than it is on top, this is like doing 1 over 10, right? Versus like 1 over 100 versus 1 over 1,000,000. Each time I get larger and larger on bottom, if we look at this pattern of getting larger and larger, it's going to go towards 0, but it's never going to hit 0, right? We keep dividing something into smaller and smaller pieces. We're still going to have something, right? It's still going to be there. It's just going to be really, really small. It's going to be almost nothing at some point. Okay, so those are those two. What do we do if they're the same power? How do we find its horizontal asymptote?
So this is number 12, right?
Mm-hmm. Yeah.
Okay. The same power of the domain and the vertical asymptote is the same power. Is that what you're referring to?
The numerator and the denominator are the same power.
Oh. Oh, okay, because I was looking at it after we'd factored it out. Okay, so we're going back to the first thing here. Okay.
Yeah, when we look at horizontal asymptotes, look at the first thing, look at it in the expanded form.
Okay.
And we're looking at the largest power. So if it's larger power on top than on bottom, there's nothing we can say about the horizontal asymptote. If it's larger on bottom, that's sort of like it's getting really, really large on bottom and staying the same on top. It's shooting towards 0. If they are the same power, what are we taking?
It would have to be like 1, right?
Yeah, how are you getting that? I hope you're looking right there.
Okay.
So we're going to take the coefficients. So like 3 over 3 is what we're doing. So y equals 1 should be our horizontal asymptote. Okay. So some way we're gonna have to get these horizontal asymptotes down. Okay. Questions about them? About how to find them? Do I need to go over any Any of this? All right, so we got 3 solving problems and then we got 1 word problem. If we're looking at this and we want to solve it, and we have rational expressions and they're all being added, subtracted, what's the approach? What do I need to find on this? What do I need to do?
Least common denominator.
I want to know my LCD, and the LCD between x and x squared is going to be what?
X squared.
It's going to be x squared. My LCD is x squared. And this is solving, so I think this is like why you're grumbling a while ago. You didn't want to do that, converting them both to the same fraction. It is a little bit more work converting things without solving them. But this one, what can we do to get rid of our fractions?
Multiply everything by x squared.
Multiply everything by the LCD. And if I don't see it, I can always put these things over what?
One.
I can always put these things over 1 if I need to multiply them by a fraction. But if I do things correctly, everything should end up simplifying. So I have like an x squared and an x squared here. This is going to give me -3 plus, what is this next thing going to give me?
$13x.
That's going to give me 13x. So I can simplify with the power of x. I can simplify this thing with the power of x. And this is going to be equal to
4x squared.
Yep, 4x squared. All right, so now what am I doing? Does this look like something we've done before?
Yes, set it equal to 0.
It looks like a quadratic that I should set it equal to 0 and solve. So if I want to set it equal to 0, I'm probably going to keep the leading positive. So I'm probably going to subtract 13 and add 3. 4x squared minus 13x plus 3. Hopefully I got my signs on this thing right when I did it. But I think I'm going to need something that multiplies to 12. And what subtracts the 13? I think 12 and 1 are my guys on this one, maybe. 4x squared minus 12x minus 1x plus 3 is equal to 0. Factoring this thing, if you want to use the box method, you can use the box method here. If you want to group and factor, you can group and factor 4x. And that's going to be what? X minus 3 minus 1 and x minus 3. My two factors are 4x minus 1 and an x minus 3, so I'm probably going a little quick over this. But we've done factoring, we've done quadratics a few times. I should either get this thing is equal to 0 or this thing is equal to 0. If this thing is equal to 0, x is a positive 3. If this thing is equal to 0, 4x is 1, or x is 1/4. Okay, I have these things. Are these solutions? Is my next question. Are they solutions? How do you know?
We can check by plugging them back into the original equation.
Yeah, we can go back to this thing. We can plug them in. Should they work? Is there another way to check? Maybe. What can our x not be in this thing?
This one would be 0.
Yeah, 0. So as long as we don't get x equals 0, I think we'll be okay. You should probably go and plug these back in if you're on a test or something, but I don't want to spend too much time on it. Okay, so the next one. Oh man, did I give you this? Okay. What can I do with this thing? If you want, you can put 0 over what?
1.
If you want to do, you can put 0 over 1. That might help you out. But what are we really interested in? I mean, maybe you could give me a domain restriction, right? X cannot be what number? If I wanted to ask the domain of this thing.
86.
Yeah, maybe I'll really confuse you then. So if I wanted the domain is coming from the bottom. I can't let the bottom be 0, right? But what makes a fraction 0?
The numerator being 0.
The numerator being 0. So if x plus 99 is equal to 0, and if you did 0 over 1 and you did your little butterflies, you'd get the same thing, right? But what makes this 0 is when the numerator is 0. Okay. And so if I want to solve for x, I'm hoping this one didn't take you too long if you see it, right? It's what makes the numerator 0. All right, so we got 2 more problems. I think Miss Watson buzzed out already. It's 10:20. If you got to buzz out, I guess you got to go if you got to go. This is 1. This is x plus 2. That's x plus 3. I believe if we factor this thing right quick, this is x plus 2 and then x plus 3. And so what do I want to do if I'm doing rational equations and they're being added and subtracted? First thing I want to find is
Least common denominator.
the LCD. So what is my LCD here? If I'm looking at this thing.
X plus 2, x plus 3.
X plus 2 and x plus 3. If I say x plus 2, x plus 3, this guy's accounted for in here. This guy's accounted for in here. And that guy, he's also accounted for in there. So if that's the case, how do I get rid of my fractions? I take each of my thing. I take each term. And I multiply by what?
Least common denominator.
My LCD of x plus 2, x plus 3. So I take 1 over x plus 2, I multiply it by my LCD. I take 1 over x plus 3. I'm multiplying this by my LCD. And I'm running out of room on my paper. But this is equal to that other half of the equation, which looks like 2 over that stuff. Over x plus 2, x plus 3. We factored that already, so I would probably keep that factored. And I'm going to multiply this thing by x plus 2. And if we set things up correctly, if we got the right LCD, they should really start simplifying, right? My x plus 2s, and if you have to write these things over 1, you can write these things over 1. But this part should give me x plus 3. This part should give me an x plus 2. And this is all equal to what I have here. These simplify. And I think this side is just giving me that 2. I think we're almost there. This is a first order equation. So I don't know I have parentheses, but this is just all addition, subtraction. This is what, 2x plus 5 equals 2. So combine like terms. It's a first order, so 2x equals, if I subtract 5, gives me -3. X is a -3/2, I believe is what I'm getting. Question? Are we getting this?
Yeah, that makes sense.
Okay, so did I do that right? Let me double check.
It looks like it works.
Yeah, and if you want, you could go plug this thing back in, see if it works, but it should definitely work. I don't want to spend a lot of time doing that, but we should be able to plug it back into this thing, make sure it works. That is something we can absolutely do. We can check it. Last thing is this thing. Evaluate P of 0 and interpret its meaning. So we have a function that models bird population in thousands of birds given by that thing. 10x plus 100 equals 0.5x plus 10. We want to evaluate P of 0. What does that look like?
So we plug 0 into all the x's.
Yeah.
Okay, so that's just 100 over 10 then.
Yep. Let me put my line down there. 100 over 10, which gives me what, 10? P of 0 is 10 is what I'm going to get when I plug in my numbers. So what does that tell me? P of X is your population, bird populations in thousands of birds. X is the number of days. Whew. There should be an X there, where X is the number of days after January the 1st, 2020.
Right, so on January 1st, 2020, you would have 10,000 birds.
Yep. Start with. That is our initial population of 10,000 birds. Determine the horizontal asymptote and interpret its meaning. So how do I find my horizontal asymptote on this thing?
Both variables are to the same power, so we would divide 10 by 0.5.
Exactly. So this is, we're looking at the powers on our numerator and denominator. They are the same power, so we take the coefficients and divide them. But if we divide 10 by half, that's the same thing as like multiplying 10 by 2. It should give us 20. So what are we saying? There is a y, I guess you could say y equals 20 or p equals 20, right?
Oops, yeah, I put x, y equals 20.
What is that telling me about my population of birds?
20,000 is the highest that can be sustained in that area.
Yeah, so 20,000 is the highest sustainable population. We have some sort of line here at the y equals 20 line. We have some sort of population that's coming up to it, is what's happening, right? We've looked at these sorts of graphs before. We got some sort of population that's coming up and leveling out as it reaches there. It should be going through right here at 10, I think is what we said. And we're talking about thousands of birds over here. Here we're talking about days. It's kind of the sort of the picture I got in my head. So that is giving us a limit, is what it's kind of giving us. It's like, can't go past that. Can't reach it, right? Definitely cannot going past it. Questions about anything? About being able to find these asymptotes?
If you keep going on the graph, it starts to go down.
This thing, I think it keeps going up.
Okay.
It just never reaches it. It just gets really
Oh, it never
infinitesimally
reaches
close.
it. Okay, okay.
Yeah, I could like probably model it right quick if you want. 10x.
It's like one of those graphs we were doing where it almost touches the axis, but it doesn't.
It almost touches the asymptote, right? Is that what
Yeah,
you're saying?
asymptote, yeah.
0.5x plus 10 plus 10. If I did this right. Where are you at? Share my Desmos. Can you see this now? There we go. It should look something like this, right? If we want to do y equals 20, it's this line. So if we go out here, right, it's going to get really, really close and keep getting closer and closer, but it will never quite hit it.
Does it ever level out either? It doesn't either then.
It doesn't ever
what you're
level
saying.
out. It keeps going up,
Yeah,
but it just keeps going up slower and slower, so to
right.
speak, right?
So the numbers just keep getting tinier and tinier.
Yeah. And
Okay.
so we might go we might go like one spot between here and here, and it might go up like half a cent, right? And we might go like a million spots between here and here, and it'll go up like half a cent. So like it takes a lot longer to go up. Like the rate that it's going up decreases dramatically, right? And it never quite hits it. All right, I think that's it. That's the final problem. Y'all got any questions? I'll be around. I got office hours today. As always, you're always welcome to stop on by my office hours. I'm going to stop sharing the screen and probably stop the recording pretty soon.